Hello and welcome to this video. In this video we are going to start a series of videos about Svelte. It will be part of the series of videos about web and especially the front-end web development. But in this type of the videos that you are producing in this channel, we are trying to go to details and deeply explain the concepts. While we are learning a library, we will also learn a lot of programming concepts. So the most important thing to learn from is using the documentation of the library, the official documentations, and to also in this video I like to highlight that the way that you want to learn from the documentation is really important, because documentations and the words and the concepts that you see in the documentation are really important. So for example, if we look at the definition, official definition, it says that Svelte is a framework for building user interfaces on the web. So this is a really important, one sentence, but really important. So Svelte is a framework, it's not a library. So what is the difference between a framework and a library? A framework is a frame, so you are inside a frame. You cannot go outside the frame. You should be inside the guidelines and the rules and the restrictions of the framework. So the rules and restrictions that are defined by the framework, you will be inside that. That's why it's a frame of work. Everyone that works in the same project needs to follow the rules and the guidelines set up by this framework. Library, on the other hand, is more flexible, and it's a written code by some other people, same as the framework, but with a lot more flexibilities. You can write the code in a way that you want. For example, in React you can be more flexible, and you can just install React in a simple way and just use it as a library, as a simple library, or you can turn React into a framework like Next.js or Remix or whatever you want to follow for the guidelines and for the rules. But React, for example, alone is just a library, because it will not restrict you to follow and it will not put you into a frame while working. But a framework puts you into a frame while you are working on that project. Okay, so it's for building interfaces. Okay, what is an interface? Interface, if we look at the words, when user enters or faces or opens a website, the user faces some elements, some colors, some shapes. So this is called user interface. It will allow user to interact with the website in a friendlier way, to be able to use the website or web app in the easy way. As the last part of the sentence mentions clearly that this is for web. It's not for native Android, it's not for native iOS, it's for web. So we are inside the browser. Whenever we are in the browser, we need to have JavaScript, CSS, HTML at the end, because this is how the browsers work. The browsers cannot understand, for example, TypeScript. The browsers cannot understand Java, especially the current version, the most popular ones that we have. So the other part of the definition clearly mentions that we need a compiler. Why? Because we need to compile the code, the declarative components, into HTML and CSS and JavaScript to allow the browsers to be able to render the website and to process the website and to be able to show the website. Very important word. We have declarative components. So this is really important while you are learning a library or a framework. Each word is really important in the definition. So we need a compiler to compile the declarative components. What is declarative and what is component? We know components is easy to understand. It's small pieces or small parts or small elements for usability and to use it in combination with other components, other small pieces, and create larger components, and at the end create the full page and also the full app. But what is declarative? Because this is really important. To understand what is declarative and what is imperative programming, we need to know what is this, what is declarative and what is imperative. These are the programming paradigms. So each programming language has a style or has a paradigm. So these paradigms are mainly divided into two sections, imperative and declarative. So if you want to read more about this and go to the website to look at the definition of this, programming paradigms are a way to classify programming languages based on their features. A language can be classified into multiple paradigms. The programming paradigm is mainly classified into two types, imperative and declarative. So now we know, while we are dealing with Svelte, we are in the right side of the programming. Now we are going deeper to understand what's going on. So let's also learn imperative to be able to understand what is declarative. In the imperative type of language, the programmers instruct the machine how to perform a task by writing step-by-step instructions, including variables, conditions, loops, everything. So, for example, when you are hungry, you go to kitchen and you make your own food by adding the necessary ingredients and following the cooking instructions. Similarly, in the programming, we have languages like C and C++ and Java. By the way, Java nowadays is multi-paradigm, but Java is popular for object-oriented style, so it is more known as imperative language versus declarative. But now you can also use Java as declarative as well. So you want to search, for example, an element in an array. So in this case, in the imperative style, you will give all instructions like getting the array, iterating over the array, checking if the element is found or not, and returning the results. This is imperative. Now what is declarative? Because now we will be dealing with declarative mostly, because Svelte is declarative. In the declarative type of the language, the programmers instruct the machine what to perform without any instruction. Oh, so that's interesting. How we can tell a machine to do something without giving any instructions? The programmer asks for the desired result. So for example, same example but in a declarative way. When you are hungry, you order food from a restaurant, for example. You don't know how the food is made. You just asked for a desired food and it is delivered to you. Interesting. So now we are not doing the full cooking. So we just want to get a food, we will get it directly. So in the programming example, let's say SQL or SQL, whatever, structured query language, belongs to the declarative. So for example, when you want to select all the uh, records in the employee table, for example, this is database related information. It's a bit far from front-end web. So in this query, you just mentioned that you need all the employee records from the table of the employee. However, you didn't specify step-by-step instructions, how and the logic, how to retrieve the data from the table, and you don't know the underlying logic used to fetch. You don't know how this SQL language is getting data, or how it works and how it fetches the records. We just write a query, the query will get the results. So if you go to the number 4, imperative classifications, so in the imperative paradigm is further classified into two types, procedural and object-oriented. Object-oriented is studied in most of the universities or whatever, but it's not the only paradigm that is imperative. We also have procedural as well. So procedural language breaks down a task into a collection of procedures, aka subroutines or functions to perform a task. It maintains the global variables to manage the state of the system. C, Basic, Algol, and these languages are all procedural oriented paradigm. So we can see an example here. It's a linear search in C. It's all procedural, so you have to give instructions in the procedural way to make it work. Object-oriented is it breaks down the tasks into objects that expose the method and the data and the object. They all communicate as an object. That's why it's object-oriented. So for example, in the object-oriented way, if you want to do the same linear search in Java, we can see it's different. So we have array search, it's a class. Then we have a public method, and we also have a parameter. It's an array of integers, for example. So we have two public methods for this class and this object. So as we can see, whenever we want to run the main application, we get the, for example, array, then we will go and do the search using object-oriented programming. So declarative is also divided by two main categories, which is functional and logical. So functional programming, which is really common in the web and very famous, very popular, very trend, for example, is part of this paradigm, declarative paradigm. So functional programming contains only functions without mutating the state or data. This is really important. So the functions should not mutate the state or data. It means that there are no global data and variable dependency, or it's called pure functions. So the pure function is a function without side effects, so nothing from outside will affect the output of this function, which means the function purely relies on inputs to result outputs. So composing and applying the function is the main driving force in the paradigm. A function can take another as an argument and returns a new function. The first high-level functional programming language developed in 1950. It is called Lisp. This language is laid foundation for many characteristics of the modern functional programming. What is logical paradigm? The logical paradigm has its foundations in the mathematical logic in which the program statements express the facts and rules. So the rules are written as a logic clauses so that the engine infers and the answer to the user query by using the unification and backtracking techniques. So for example, the prologue program to infer relationship match of two people from their food interest knowledge base. So it will be something like that. The facts. So boy Tom, boy Bob, and boy Jerry. Reads the Tom is a boy and it's a function. Girl Alice, girl Lily. So this reads the as a function. So this reads the Alice as is a girl. And this is for chicken, this is for fish, this is for fruit, and for apple, and whatever. So until the end. So if we see eat Tom chicken, it means Tom eats chicken. Eat Tom apple means Tom eats apple. So it's really clear by the function what the function does. So human is a function also. Boy is a function. Girl is also a function. So X is a human being if X is either girl or boy. So as we can see from this example, it's really clear like how the functional programming works. So it's a function, but this function uses two other functions. So this or this is the logic. So if this is true, it means this is either this or this. If it is true, it means that this is a human. Is it vegetarian or this is non-vegetarian is also another logic. So everything is relying on the logic. Like if this is true, this is false. This is true, this is false. So this is highly logic based thing. So how we know this is like a two-person match is basic on the logic and the true falses that we get. So this query checks if Bob likes Alice or not, and this query checks if Bob likes Lily. So as we can see, this is logical declarative programming. So that was a quick dive deep into the paradigms of the programming and to understand now better how the Svelte works as a declarative component library framework that will be compiled into HTML and CSS and JavaScript. Okay, let's quickly look at this structure of the components that we get from Svelte. As we can see, the files are .svelte. In this file, we have script, HTML elements or components or whatever you call it, it's okay. And then we have styles. So we can see it is tightly optimized JavaScript, as we can see, and you can use it to build anything on the web, from standalone components to ambitious full stack apps using Svelte's components application framework or Svelte kit and everything in between. So these pages serve as reference documentation. If you are new to Svelte, we recommend that starting from interactive tutorial and coming back here when you have questions, and you can also use a playground from the options that are available from the documentation. So now we know that now we have an idea about what is Svelte and how it works and how it is built and which programming paradigm we will be following. So next section is getting started with Svelte. So to get started with Svelte, you need to have, of course, npm Node.js and be able to run this locally on your machine. Okay, interesting. What is Node? Why we need Node.js or npm? npm is Node package manager, but why we need Node? Why we need Node.js? What is Node.js? So let's quickly search about Node.js. What is Node.js? So if we come back to AI definition to keep it to quickly get a result from AI, for example, Node is a free open source cross-platform JavaScript runtime environment that allows developers to execute JavaScript code outside of the browser. Interesting. Every part of this definition is really important. First of all, it's open source. If it is not open source, we have to pay or do a subscription or get an API key to use it. But it's open source, so you can just download it and install it freely, and we can also see the entire code, how it works. So if you go to the Node.js website and you look at it, how it works, it will be a dive deep, and we can see it is mainly built in a way that to to run the JavaScript outside the browser, inside a computer locally. So we will be dealing with machine code. So if you go to the documentation of the Node.js, and if you read the about section, and you can see the information about the way that the Node.js works and what are the capabilities of the Node.js, what you have and what you can do using this environment, runtime environment for JavaScript. So the basic idea is outside the browser, computers does not have access to JavaScript, does not be able to run JavaScript. To allow users to run JavaScript on the computer locally or on a machine outside the browser, because only browsers can run JavaScript, HTML, CSS and be able to use it. But outside the browser, how we can test it, how we can run it, how we can build it? We need an environment somewhere to be able to do that. That environment is called Node.js. So Node.js is not a language, Node.js is not, let's say, a library or a framework or something like, nothing fancy. It's just like let's say a container that allows you to run JavaScript without being inside a browser. So it's like a browser, but you are not inside the browser. So it allows you to run the JavaScript. That's it. So coming back to the Svelte, so now we know that what is Node.js. We want somewhere to run the JavaScript. Now we need packages. So let's say this Svelte or whatever you are using, it should be hosted somewhere that we can download the code and easily get it. So that's called npm. So what is npm? npm is a website or a server that hosts all these packages, these libraries that we can download, and it is built by other people. We can have access to it and we can download these packages and we can use it. So why this is important? Because in projects we might use a lot of these packages, the code from other people, directly or indirectly. Oh, why indirectly? Because when we use Svelte, we think we are just using Svelte. But Svelte also uses other packages under the hood. So these packages will be installed and it will be used by Svelte itself without we installing those packages directly using our command line or CMD. So not only the packages that we install, the packages that also other packages rely on also will be installed. So we will be dealing with a lot of packages here. So if we install everything and let's say we copy to or deploy to a server, we want to copy this folder, it will be almost impossible for you to copy and move the folder of the project. So the correct approach is we don't copy the installed packages. We just move the project without these packages being installed. It's easier to move to the second device, then install it. It will be much faster than copying the packages to that computer from computer A to computer B. That's why node modules are always ignored in the Git, and also it is not copy pasted to other computers or other devices because it will be really hard. So this npm.js is really important because every time we want to install these packages, we need some really fast server to be able to download and to use it. We have npm, we have pnpm, we have yarn, all of them download from the same main server. It's just for the way that they manage this process and load to balance the loads. So now we understand what is Node.js, what is npm, and what are these packages. The packages are the code that are written by other people and published for us to use. It could be open source, or it could be free, or it can be premium and paid. You need an API key for using some of the packages. Okay, so now we have a JavaScript runtime environment. We can install the code from other people and we can use it in our machine locally. For example, Svelte. So Svelte is a framework that is built by other people. We can see their GitHub repository, we can access it, and we can look at the code and how these people are building this Svelte. So this is the Svelte. As you can see, here you can see the entire code, what is Svelte and how it is built, and it's open source. You can have access to the entire code, you can contribute, you can report an issue, and you can be part of the Svelte and be part of improving this community of libraries and frameworks. So the official documentation is recommending Svelte Kit. So what is Svelte Kit? So if you are new to the Svelte or Svelte Kit, we recommend you check this tutorial. And if you get stuck, you can reach to the Discord. So what is Svelte Kit? Svelte Kit is a framework for rapidly developing robust, performant web applications using Svelte. Oh, Svelte is also a framework. Now there is a Svelte Kit. Svelte Kit is also another framework that helps you to build faster and robust and really good Svelte applications. So Svelte Kit is like a kit, it's a framework on top of the Svelte framework. So it allows you to develop robust, performant web applications. So these are the three claims that this Svelte Kit will provide to you: robust, performant web applications using Svelte. So if you use Svelte alone, you might not get a robust, performant web application. But if you use Svelte Kit, it will help you to get robust, performant web applications. So if you are coming from React, SvelteKit is similar to Next.js. If you are coming from Vue.js, SvelteKit is like Next. So it's like a framework on top of another framework. To learn more about these kinds of applications you can build with SvelteKit, you can see this documentation regarding the project types. And what is Svelte? Now you're coming back to the Svelte definition. It's a way of writing user interface components like navigation bar, component section, contact form, everything that you can see as a component. Here you will get more detailed definition. So SvelteKit versus Svelte. Svelte renders UI components. You can compose these components and render an entire page with this with just Svelte. But you need more than just Svelte to write an entire app. So the SvelteKit helps you build web apps while following modern best practices and providing solutions to common development challenges. So this is the importance of using SvelteKit. It offers everything from basic functionalities like router that updates the UI when a link is clicked, to more advanced capabilities. It is extensive list of the features including build optimizations to load only the minimal required code, offline support, preloading pages before user navigation, configurable rendering to handle different parts of your app on the server via a server-side rendering. So it's a full kit. It gives you everything that you need to build a really modern, really performant and really good web app. So it is a helper, or let's say a framework on top of Svelte framework to help you build better websites and web apps. So that's why the documentation is recommending you to use SvelteKit, which lets you to build almost anything, and it's really helpful. So the alternatives to, let's say you don't want to use SvelteKit. It's too much, for example, for you. You don't want to learn another framework on top of another framework. You want to keep it simple, and you want to keep it minimal. So at that case, you can do it through Vite or Vite, whatever you call it. You can use Svelte directly without using SvelteKit. So you will create a Vite project, and this Vite project will provide you the setup that you need to run a minimal Svelte project. So now we're talking about how many ways we have to start a Svelte project. Either we will go to SvelteKit, or we will use Vite plugin for Svelte to set up using Vite. Each of these we will dive deeper to it, what is SvelteKit and what is Vite plugin for Svelte, in the future videos. So it's really important for you, if you want to stay in this course and in this series of videos about Svelte and deeply explanations of the concepts and the terms that we see in these documentations. I highly recommend you to subscribe and also to be notified whenever a new video will be released to this channel regarding Svelte and also other frameworks that we are going to host in our YouTube channel. So that was all about this video. I hope it was a good starting point to be able to understand Svelte and understand how it works before deciding to choose it for your web applications and websites that you are going to build. Thank you so much for watching this video, and see you in the next one.